Today is Tuesday, February 26th, 2019. This is an interview with Michael Karmis, Stony Barker Professor of Mining Engineering and Director of the Virginia Center for Coal and Energy Research at Virginia Tech. The interviewer is Craig Luxbacher. This interview is being conducted as part of the American Institute for Mining, Metallurgical, and Petroleum Engineers Oral History Project. We are sitting in the Hyatt Regency, just across from the Convention Center in Denver, Colorado, where the SME annual meeting and convention is currently underway. And we are going to discuss his experiences in the mining engineering industry and his contributions to the field. Michael, you were born in Greece just after the end of World War II. Tell me what it was like where you grew up.
Yes, I'll be glad to do that. First, I want to thank AIME for the initiative to develop these oral histories, and for you for being here and be patient to interview me. I was born and raised in Greece, in Athens, in the late 40s. It was just after the Second World War and a very bloody civil war that Greece had. So it was a difficult time. My family were all military people and very much involved during the war. So I grew up in Athens. My parents were from a very old historic city in the southern portion of Greece in the Peloponnese called Nafplio. It's a beautiful city by the sea. It's still my favorite place and my children and grandchildren's favorite place. I had a very pleasant, I would say, family-oriented experience in going to school and living in Greece. It was a time mostly of Greek reconstruction in the 50s. I went there through all my schooling, and I finished high school in '66. Not sure exactly what I'm going to do next. As I said, we didn't have any engineers in the family. Military was the main thing. We had some doctors, but I thought I should become an engineer. And I had an interest to go and do this somewhere else and go overseas and travel. So simply because of a series of coincidences, I had an opportunity to go to Scotland, and that's where I went. And I did all my degrees there at the University of Strathclyde, which is an urban, historic downtown university in Glasgow. My first thought was to become a civil engineer. I noticed the civil engineers at that time, they were opening offices and making money, building anything and everything. So if somebody wanted a job and do well, it was going to be either a civil engineer, a mechanical engineer, or an architect. That was the whole building sort of bonanza that was going on. But interestingly enough, after halfway through my first year, I got a little bit interested in mining. I had friends who were in mining and engineering. I liked the department. It was a smaller department. It was very historic. So I moved over from civil into mining, and I think that was the first good decision I've ever made. So I'm moving forward from Greece into Scotland now. So a Greek in Scotland. It was an interesting experience. The Scottish people are tremendously intelligent, very innovative. If you see how many inventions they are credited with, it's quite incredible. The university was very old and historic. We had the James Watt Laboratory. John Logie Baird, who was the inventor of television, had been there. And mining was very traditional for that university. The faculty were outstanding, a smaller department like we're here, very nurturing. So I had a very, very good experience, and I enjoy every minute of this. And after 4 years, I was asked to stay to do a graduate degree, which I did. I was serving as an instructor at the same time, and I enjoyed teaching, so I thought that was something that I would like to do at some point. And I graduated 71 with my BS degree, 74 with my PhD. And I met my wife of many, many years, Vivian, in Scotland. She was of Italian descent, so here was a Greek in Scotland and an Italian-Scottish girl. So by the time I finished my PhD, we got married and so we started having children. And I had to decide what I should be doing next. And Greece, if you may recall, in '66, he ended up having a military junta. It was a horrible government. My father, being a military guy, totally objected to this. He discouraged me to go back, and I did not. But the junta sort of was moved away in '74, and at that point that opened again an opportunity for me to go back to Greece for a little bit. So after spending time in the UK, in Scotland, 9 years, excellent time, very productive technically and academically, making many friendships with people, I decided it's time to go back home. So we took our 2 kids, born in Scotland, but moved with us to Greece, and I worked for about 3 years at the National Technical University, which is the main engineering school in Greece. I enjoy my time there. I enjoy teaching. I enjoy the research. I got close with a number of mining industries, both metal mining as well as coal mining. A little while later, I got a little bit the urge to do something a bit bigger and move again. And this is an interesting story. I was thinking of going back to Britain, and Imperial College was talking to me, the University of Nottingham and Strathclyde, where I was. And one day, an elderly gentleman came to my office, and he said he was a professor in an American university, and he had an appointment with a colleague. And his colleague wasn't there yet, so I said, well, come and sit in my office until your person arrives. I said to him, well, I'm here in the mining department, but I will be going for a sabbatical for a few months in Great Britain. And he said, Great Britain, why didn't you come to America? Well, I said, I don't know anybody there. I must be the only Greek that doesn't have a relative in Chicago or in Queens, New York. What will I do? I mean, it doesn't make any sense to me. No, he said, I am a professor at Virginia Tech. He was a graduate of that Greek university, but he had a PhD from MIT in chemical engineering and then in metallurgy. And he was one of the original faculty members in metallurgy at Virginia Tech. And he had a very good Greek name, Themistocles, a very historic ancient Greek name. So he said, I think Virginia Tech would like you to be there. And I said, okay, and I just dismissed this. And then the next day I get a phone call from a gentleman who said his name is Dick Lucas. He's the head of the mining department at Tech, and if he sends me a ticket, can I come for an interview? I said, you're going to send me a ticket all the way to come all the way over there for an interview? He said, yes. So I said, why not? I'll do it. So in June of '78, I arrived, and I loved the campus. It was, I was always in urban universities, so coming to a campus rural as Virginia Tech is, a little bit of a military kind of architecture, it was quite impressive. I liked the department and the people that were working there, so they offered me a job right there and then to be a visiting professor, and they insisted that I should know this is not a tenure-track position. Now, I didn't know what the term tenure meant. I never heard it before. And in Britain, you are either permanent or temporary. There was nothing in between. So I had to ask people what really that means. But anyway, I said, don't worry, I'm not going to stay here more than 1 year. I moved on my own because our 3rd kid was just about ready to come, so Vivian stayed behind in Scotland. So she came with the three kids. I was busy. We had a good time, and they asked me to stay 1 more year. And I said to Vivian, what do you think? And I said, 1 more year is okay. And then after 1 more year, there was another year, and then at the end of the day, currently I'm on my 40th. I just clocked the 40th year at Virginia Tech.
So Michael, backing up a bit to your time in Strathclyde, were there any professors that were particularly effective mentors to you?
Yes, there were. The department head there was a very well-known and worldwide rock mechanics person. His name was Dowie Jenkins. This is a Welsh name, and he did have a very pronounced Welsh accent. And then my advisor was a real gentleman. He was also a Welshman, although they were all in Scotland. His name was David Davis. And he was a wonderful individual. He became a very close friend afterwards. But they were always motivating. It was not a relationship of student to a professor. It was more a colleague to colleague. They gave me freedom to do as a graduate student anything that I want within the confines of my work. I was in their house many times. We had a very long-lasting relationship. They both have passed since then, but they were wonderful people. And in fact, the entire department was a very caring department. You can ask for help or advice, and it was really a very good environment for everybody. It was also a very sociable department. I've been in Scotland and having a little bit of affinity to have a little glass of whiskey every so often. And the department often ventured to these activities led by the department head. But it was both socially as maturing throughout the years, and as well as professional education. It was very good. I will tell you an interesting, funny story. In Wales, there are certain prominent names that 80% of the population have the same surname. Jenkins is one, Davis is one, Edwards is one, Evans is one. These are really very, very common names. So David Davis, who was my advisor, was telling me a story. When he went to school, there were 5 David Davises. In fact, they had the same middle name. They had David O. Davis. And they had to pick up a nickname, because at that point all exams were in writing, right? So you didn't put a number or a code or anything, you wrote your name. So in order to get graded rightly, you had to pick up a name. And it was just after the war, and many of the students at his time, he was at the University of Cardiff, they were serving during the war, so they were much older than him. So since they were 5 David O. Davises, and my guy was also a rugby player, so he wasn't drinking, he wasn't smoking, he was very athletic. He had a nickname. He went through school known as David O. Lemonade Davis, because every time they went out to a meeting, everyone was drinking beer and he was drinking lemonade. So it was quite interesting. But all these folks that I met and worked with, and we became very friends, they were excellent mentors to me.
What was the mining industry like in Great Britain at the time, and how did that influence your graduate studies?
Yeah, this is a very important question. I was at a time where coal mining was extremely important, and you're too young to know this or to remember, well, you wouldn't remember it, but we had a very prolonged miners' strike in the United Kingdom. It was so prolonged and intensive that actually toppled the government of Edward Heath, who was then the Prime Minister. Everybody who lived through this would remember, because the power companies would cut the power around 5 o'clock at night. I mean, the whole of Scotland was dark. There was no television. That helped improve the birth rate after a few months. But in general, it was a horrific time. And eventually there was a negotiated agreement, but Britain was very much dependent on coal for power generation. Coal mines and coal miners were very unionized. That meant certain things they were done because the union did a good job, and other things they became more political, that union issues, if you will. So the coal industry was a very vital industry. And of course it was nationalized, and it was part of the National Coal Board. They had great researchers there as well, and many of the techniques we use here today in coal, particularly in ground control and ventilation and other topics, have come from principles and ideas that were brought out of that. Britain also, as a country, was a global player in the mining business. And now you have to go back and think the British Empire in terms of influence, let's say, in Africa. So while I was a student, there were all the time companies from South Africa, companies from the Far East, big mining countries coming to the university to give seminars and interview. So the domestic mining industry in Britain was primarily coal. There were some industrial minerals that were active, but the university had very close ties with mines in the Africa continent, in all the African countries, as most British universities did. and also on the countries within the Commonwealth. So we had a lot of Canadians, for example, coming back and forth. So it was at that point a coal mining country with a significant dependency, if you will, in coal. Interestingly enough, when I was an undergraduate, you could actually specialize in coal mining or what we call metalliferous mining via electives. I chose metalliferous mining because I thought I would like to do more metal mining. Although later on, when I went to graduate school, all my work was done in coal mines. So.
Did you work closely with industry while you were in graduate school?
Yes. We had a number of projects that were mostly with the coal industry. These were the British version of longwall mining and the way it was practiced in the UK, usually advancing longwalls. And we had a number of projects funded by the National Coal Board, so we worked very closely with them. But we also had projects with companies like Anglo-American and other international mining companies who came and worked with us on a number of projects. As I said, the department head was a very well-known figure in rock mechanics at the time. So we did work with them. As an intern, when I had the opportunity, I would visit or work for a short period in mines, and I had experience with an underground clay mine in Scotland, which was one of the very few underground sort of mines that were there, that in the industrial minerals arena. Then in Greece I had an exposure in an underground bauxite mine, and most of my work was performed in a coal mine which was one of the star fleet of coal mines in Scotland. It was Hiccocks Colliery. It was a very interesting place, and the manager had taken a liking at me, and every time I used to go to the mine, he asked me, where is the Greek wine? Otherwise I cannot get to the mine. So, but he was a wonderful guy, also a great mentor. It was a very good experience.
So you returned to Greece and joined the faculty there after Strathclyde. Tell me a bit about the mining industry in Greece at the time and what the faculty were engaged in.
The mining industry in Greece actually is very diversified, and for Greece and the size of Greece and the economy of Greece is quite significant. Starting from the coal side, they obviously mined lignite more than coal, the lower quality, but a huge production in northern Greece and a bit in southern Greece. Again, dependency in power generation on the lignite mines. Greece was also a big country of producing and exporting bauxite in the aluminum business. So there were both surface and underground mines in bauxite. Also a lot of industrial minerals, magnesite, perlite, bentonite. And in certain cases you will have some of those mines and mining areas that they went back to the antiquity. I mean, there was mining there, thousands of years ago. And in north of Greece, there was quite a lot of interest in gold-bearing strata, which is still is to now. So it was quite a diversified industry, and also a significant marble industry. Marble was at that time already a big building material, and you see a lot of marble sculptures in Greece, so it was the same in the ancient world. So Greece had quite a diversified mining industry. There was only at that point one mining department in the country. The faculty there, particularly the senior faculty, were very much engaged with the industry. They served on board, they served as consultants, and also with government agencies. They were consultants or advisors. When I went there, the head of the department had to take time off from working full-time in the university to be the chairman and CEO of a new company the government put together, which was to develop offshore oil and gas deposits, which actually still exist till now. So it was an active department with a lot of diverse experience, and it was a department that consisted of the mining engineering program, the metallurgy program, and the geology program, all together within the one sort of entity. And it was quite a historic department as well. So it was, from the mining point of view, a very good experience. I worked with very good people there as well. and we had quite significant size of student bodies. But the research was not organized. It wasn't like here or where it is now, where there were research programs to write proposals to get money. All that started when Greece joined the European Union, and that research infrastructure became a little bit more formalized.
So when you did come to Virginia Tech, tell me a bit about your first big research project.
When I came to Virginia Tech, it was the fall. We were then in quarters, let me say this. The faculty loved the quarters, and the students loved the quarters. The administrators hated the quarters because they had to do more things 3 times a year than twice a year. And I was also there when we had this painful experience of moving from quarters to semesters. The other difference is that at that time, we started actually mid-September, which what most of the world does, except the US. But in our system here, if you start mid-September, it means that the football season starts a month before the students are at home, and that wasn't a good thing. So that's why we moved from quarters to semesters, and then we moved to early semesters starting in August rather than mid to late September. So the first project that I did when I came to Virginia Tech, there were already a number of active ongoing projects, and they needed help in rock mechanics in 3 of these projects. So I had the convenience and the pleasure and the flexibility to work on research projects which I did not help bring into the university, but they needed me to work and contribute to that. So this was traditional rock mechanics projects, exploration and development projects, and health and safety projects. All this were funded, as I said, before I came to Virginia Tech. The first project that I got, that I was the PI and wrote most of the proposal, dealt with issues of prediction of mining subsidence. And that was followed with another big project with another colleague and a dear friend who has passed, Chris Hiccocks, and to do work on multiple sea mining conditions. So these were the first projects that I did, and I was able to hire and pay students to work on these projects, which was quite an interesting experience. I think, although I never admitted to the students, I learned as much from them as they learned from me. It was a back and forth experience, and I was very pleased to see over the years with many projects that we did. A lot of them became academics, others went to industry, others stayed for a master's, they didn't want a PhD. And I'm very happy that I had very great relationship both with the undergraduate students who have graduated as well as the graduate students.
Who were your early mentors around that time?
Around that time, the department had some real characters, and Chris Hiccocks was one. He was basically educated as a metal miner from Camborne School of Mines in Britain and then Rolla, Missouri. He worked for De Beers, then he went back to work for De Beers in South Africa. So he was a diamond miner, and he was an expert on slope stability, which was their big issue. Then when he came back to the US, he got his PhD at Rolla, and then he went to work for the US Bureau of Mines in Denver. And then from there he came to Virginia Tech. He fancied himself always as the metal miner, but most of the research money they were in the coal business. So him and I did a lot of work together. He was a great mentor. He had an exceptional sense of humor, not always the most appropriate sense of humor, but he had definitely one. He loved the students. He was very popular with the students. He was a great ex-rugby player, so he knew all the rugby songs, which he insisted to teach his freshman class or his sophomore class that he was teaching then. But he was also a great teacher. And he was a mentor to me from the point of view that he always insisted that we did a great job when we wrote papers together. He thought teaching was our #1 responsibility, but also he was the most disorganized person when it comes to anything. because I do remember when I took over the rock mechanics class from him, he gave me his notes and he said, you don't have to do anything, everything's in these notes. So I said, fine. So I started looking at these notes and there were things like, don't forget the diagram. So I looked around and I couldn't see the diagram. Tell the joke. I said, not joke. So after a while I said, I can make heads or tails in these notes. They're only good for you. But he was quite funny. But he was doing a great job in class, and I think all the alumni remember him very, very fondly. There was also another different type of professor at Tech at that point, which unfortunately, maybe we can do this with professors of practice, but usually on the tenure track academic ranks, we don't have people with an awful lot of mining experience under their belt. So there was a professor there by the name of Lou Prelaz. Lou didn't have a PhD, but he was one of the leaders and motivators in this country in computerizing the mining industry. There were similar people to Lou Prelaz with great experience at that point, also at WVU and also at Penn State. So there was a cadre of people who came to academia with a tremendous experience on their belt. And coming to, even in coal mining, where I thought I knew all about coal mining, American mining was so much different. And the regulatory environment was so much different. If I needed something or I had a question, I would go to Lou Prelaz. He knew all about coal mining systems. He was a great person. The department head was very supportive. His name was Dick Lucas. And he was tremendously well connected with industry. When I came to Virginia Tech, I didn't realize how much money we had from companies and from individuals for scholarships, for other programs. He was basically, I would say at that point, the only department head, and mining was the only department that had an endowment generated by themselves with a foundation. He understood the power of alumni. He worked with them very, very closely. And later on, when I became a department head, I thought what I saw him doing helped me a lot to do what I wanted to do as well. So he was also a great person. He did a wonderful job at the department.
I've always admired your approach to work. You genuinely enjoy your work, and working with you is a lot of fun. Was this true early in your career, or was it something you developed over time?
I always try to have fun in whatever I do, and even if I do things that I don't particularly like, I'm trying to make light of it and do the best. But it's fun to teach. I thought the educational portion was the most rewarding part of what we do. I know in the last 20 years the emphasis is on money and research, and we count dollars and all that. But I think I would be surprised if anybody in our business doesn't take more pleasure in teaching and more pleasure in seeing undergraduates doing well and more pleasure in doing things with them. It's a tremendous motivating thing. That's what I said. We get more out of them than what we give them. So I try to do this, and I try to keep a balance. I mean, you have to be serious and focused, but at the same time, keeping a sense of humor, I think, is important in life. And I have tried to take the negative out of my head. My wife sometimes gets irritated with me for doing this, but I don't have negative thoughts. I always have the good things in front of me. So I appreciate that you have enjoyed working with me.
How long were you at Virginia Tech before you became department head?
I came at, as I said, at 78. I went through the ranks fairly fast. And around, I think it was 86, it was a time for a change. During that time, most people saw the job of the department head as the terminal sort of goal. It wasn't something that you did and you stepped down in the faculty, which is mostly what we do now. So at that point, the department wanted to change, the Dean of Engineering wanted to change. So it was an interesting experience. I don't think you could do this nowadays. And now when we have a position, we have to advertise, we have to go through all these sort of process and procedures, which is good because you want to expand and diversify. At that point, the dean called the meeting and he said there's going to be a change and we will need a new department head. And one guy said, I think Chris Hiccocks, well, Michael Karmis can do it. And a couple of guys said, yeah, he'll be a good department head. So Paul Torgerson, who was then the dean, looked at me and he said to me, get out of this room. So he threw me out of the meeting. He came back after 20 minutes, said, congratulations, you're the new department head. That's how it took. And talking about mentors, Paul Torgerson, who was then our dean, and then later became, as you know, the president of Virginia Tech, he was possibly the most, how can I say, innovative academic leader that I've ever seen. He had tremendous ideas. He was a faculty person. He will be caring about you as an individual. And if you ask me, somebody that I thought he was an absolutely phenomenal individual and a true mentor, I would say was Paul Torgerson. And I'm glad that I became a good friends with him, and as you know, he passed away a few years back. But he was quite an incredible person. So I became a person working for the dean because as a department, that's what you do. And I thought I'll do it 2 terms. I thought 2 terms is good enough for the president, should be good enough for the department head. But I moved towards the 3rd term, and at that point I said, you know what, everything I wanted to do more or less is done, or I didn't do it. So there's no point doing this. So I asked, let me step down and go back to the faculty ranks. Being a department head was a very challenging time, and I don't know if you have a specific question for this.
Well, I think at Virginia Tech we credit you with diversifying our department, and we were no longer just a coal department. What sort of motivated you, inspired you to do that, and how did you do it?
Yeah, that is a very good question, and something that I'm proud of it, but also is interesting how it came up. When I went to Virginia Tech in '78, it was during an upswing of the coal industry, and the reason I joined was because the department was growing. We brought people with experience from South Africa into the mining department, from Britain into the mining department. We ended up having a faculty of 12, which was quite a large faculty for a mining department. And I would say at that point we were graduating at least 60 to 70 mining engineers per year. By the time we went to mid-80s, the coal industry had vertically plummeted. Metal mining industry wasn't doing very well either. Our metal mining friends would remember the price of copper and what happened to the copper industry at that point. And all that had a pronounced impact on all the mining departments across the country. We had about 22, I think, mining departments. There are now 14. A lot of them were lost during that period and never resurfaced. So when I became a department head, I knew how many people we had in the senior class because I used to teach the senior class, and we had 2. And one of them never graduated. He told me, he said, I'll move over to civil, maybe I can get a job in civil. And I sat back and thought, if I was a dean, would I keep a mining department at that level? And the answer is no, I wouldn't. So I talked to the faculty and said, you know, we need to expand. Not only just to expand as a small period of 3 years and forget about it. We need to change our culture. And at that point, it was obvious to me that the aggregate business, the construction material business, and the industrial mineral business, they were booming. Now the coal and the base metals, they were plummeting. And I realized that occasionally we will send a student to these other mining businesses, but they were not really our customers or our clients. So I spent a lot of time visiting God knows how many of those companies and trying to sell them to hire some students for summer internships, because I don't think anybody was prepared to hire anybody on a permanent position. And I believe the first company who said, yes, we'll do something was Lackstone, a company out of Richmond, a very progressive company in the stone industry. And then Vulcan Materials came up, and I think we impressed them with our students. So within a very short period of time, we were producing students for that entire sector, who were active participants to their national association, and we developed even a student chapter for the National Stone, it was NSSGA, National Stone, Sand and Gravel Association. I think the names have changed over the years. And that made a tremendous difference. And we did the same with the industrial minerals as well. And that made tremendous difference, not only in terms of counting bodies, but counting also in terms of diversity. We were able to recruit more women, and we were able to recruit different kids from different areas. We recruited people from Northern Virginia. And people will tell me, well, but these guys will never want to go and work in coal. Wrong. We had so many people from urban areas really enjoying working in the smaller, regional areas in the coal mines and vice versa. So gradually, going step by step, we ended up to have by far the largest mining program in the country. And I do recall in the late 80s, early 90s, Virginia Tech was graduating 30% of all the undergraduates in the US. My advice to everybody is to keep broad. We're really producing mining engineers for all commodities, all types of methods and systems, and our curriculum should reflect that. You don't want to have 20 courses all focusing in coal or in another area. You need to have, they will learn so much more themselves later on. So that helped us quite a bit to become diversified, and I think that helped the department tremendously. And one of the issues, I think maybe I was the first who coined that expression, people would say in other sectors, well, the quarries, they don't have the same issues as a big underground metal mine or a coal mine. And I said, well, you try to practice urban mining. And what I meant by urban mining is you develop an operation close to a very dense metropolitan area where all the neighbors are different, where all the neighbors are monitoring vibrations in their houses in case blasting shakes something. This is the first time people understood in mining beyond compliance, because meeting the law is not going to help you to get a permit or to operate. You have to go by far beyond that, and you have to learn to be a good citizen and a neighbor. So maybe the mining problems per se, they were a little bit more simplified, but the overall mining problems of engagement, community and all that, the aggregates people understood it so much better because they were operating in that environment. So I thought that brought another component and a dimension to that. So yes, we became diversified, and I think that helped us a lot. And even to date, as you know, we still are very diversified, and we're not only in terms of student bodies, also in the faculty. I think we're the only department that has 4 women in a faculty of 11, or how many are we now? I don't even
12.
know, 12. I think that's quite a significant accomplishment, and I personally am more energized working with women and the younger people in the faculty, and you are one of them, but we have quite a few men also who are under the age of 40 or thereabouts. So we're a young department with a lot of people with ideas that keeps us older ones, I think, on our toes, right? Occasionally, we have a young woman that is also very capable and very motivated, and I was trying to give her some advice. I'm supposed to be her mentor. She will tell me, as you know, Emily, she will tell me straight up, oh, this is a terrible idea. So I was telling her we should do this and this and this, and she says to me, oh, Michael, this is a terrible idea. And I thought for a minute, and I thought to myself, she's right. And I said, well, who the hell is mentoring who here? So I think I get mentored by you also as much as you get help from me.
Michael, you've made considerable technical contributions to our field. I wonder if you could talk about some of the ones that you feel are most significant, starting with your work in subsidence in early years.
Right. One issue that was always a very important issue in mining is the type of movements that you get in the surface because of activities in an underground mine. When I was a graduate student, I focused a little bit on ground control and rock mechanics, and I looked a little bit at as the whole system. In other words, not only look at the roof or the support of the pillar or what have you, but look the whole thing as a system and how it behaves. And that system at some point will cause enough sort of collapse of the roof and caving that you will end up with some surface movements called surface subsidence. Now, it is a necessary sort of part of mining if you're going to do a mining method that you create a large enough hole which eventually cannot support itself and it will cave. So it is very important to be able to understand what kind of forces propagate from the mine level to the surface, what is the ability of those forces to cause damage to any structure or facilities, and being able to mitigate some of those facilities or to decide when the problem will become an issue that you have to take care of it. In my view, I focused on developing certain technologies or techniques, if you will, which would allow you to predict the amount of movement in the surface, both in terms of vertical as well as in terms of horizontal movement, and try to interpret that movement into what may do to the surface. In some cases, you can control that movement by your mining system, but that's not always possible, particularly in the current modern longwall methods. So that is one area that I spend a lot of time. I was fortunate to receive significant research funding, and I had about a dozen of graduate students, some of whom are professors now, all doing PhDs focusing on this particular topic. We also, with co-workers, did quite a lot of work on ground control conditions in coal mines, which are impacted by multiple seam mining. So we try to develop better methods of prediction, better methods of support, and trying to see whether you can use multiple mining in a synchronous way so you can minimize the impacts overall to the ground control activities. So my technical contributions are focused on the ground control movements both at the underground level and the surface, and looking at it from a systems point of view. Another area that was quite a bit interested, it is part of rock mechanics as well, but goes a bit broader. When I came to Virginia Tech in 1978, it was just a year after the passage of the Health and Safety Mining Act. And at that point, many people thought that was an act that would go away after a year. So there was a little bit of a negative, I think, approach by industry, not sure whether this is going to be here to stay or is going to go away. So it took a little bit of time for both the government and industry to fully realize that there is a new set of regulations, that you have to live with this new set of regulations, and we should be looking at the technology to be sure that regulations make sense. So when I came to Virginia Tech in '78, the first meeting I attended was a meeting called the Annual Institute on Coal Mining Health, Safety and Research. This was a particular important meeting. It was designed to bring the government folks and the operators together to talk about issues of health and safety. It was a meeting that was sponsored by the research agency in mining at that point, which was the U.S. Bureau of Mines, also MSHA, who was just being created, and just about every major coal company was a participant at the level of vice president of safety. And so many research ideas were generated out of that series of institutes. The person or the professor who was sort of coordinating all this left Virginia Tech after a year that I got there. So somehow as a young faculty member, I was asked to be in charge of this, which was a tremendous experience. And we were able to think a little bit, not only on technical issues involving health and safety, whether it is ventilation limits or dust limits or ground control or spacing of bolts, but also to begin to think a little bit about the issue of health and safety management. Because we all realized at that point, and that institute actually created that opportunity, that the rules are there, engineering is there, but how people are managed and the culture of safety. And this is the first time I think there was a serious discussion about all that during that series of meetings. So we then tried in our work that they did, and we did in our research that we did, to introduce the technical aspects of health and safety, keeping in mind that that's not enough to get you to where you want to be in safety. Very soon after that, there was a national competition by the U.S. Bureau of Mines to establish what they call generic centers in various aspects of mining. And they established 5. The areas of influence were very diverse. We were fortunate enough to win the center that was called Center in Mining Systems and Ground Control. Later on, the term safety also became part of the title and part of the agenda. The other centers were in pyrometallurgy, one in hydrometallurgy, one in comminution, and later on there was another center was established in dealing with dust. And these were called generic centers. So through that center, that was a significant amount of money. We had partner universities, wonderful people, both in East and West, metal miners and coal miners working together. And this system was funded for about 10 years. It was closer to $1 million per year, which in the early 80s was a significant amount of money. And a tremendous amount of work was performed during funding from that particular initiative. Again, looking at technical as well as other issues. And we did start thinking about the psychology of safety at that point and trying to somehow connect the technical controls with the behavioral controls for the improvement of health and safety, which is now the basic book as to how you do safety. So we were able at that point to connect a little bit what we did technically with what we did with other things. So I thought that was quite an important piece. In research, I think you also have to evolve a little bit. And if you be stagnant and you say, well, subsidence is what I do and that's the only thing I want to do, or ventilation or whatever you do, you became a bit stale, I think. So a while afterwards, I got a little bit interested on the issue of CO2, the issue of unconventional gas, and I figured out that the mining guys are drilling all the wells to degasify the mines. The coal bed methane was their problem, basically. So that is an area that is more mining than petroleum engineering, in my view. So we became quite interested on the area of CO2 sequestration, which is basically after the CO2 is captured for a power station or another industrial facility, maybe you can sell some of it to make some income, but there may be more than what you can sell, and at that point you can inject it. And the idea is to inject it in coal bed methane wells or to inject it in shale gas wells in a way that will also enhance additional gas recovery. So we were fortunate that we received a series of very large projects and were able to do demonstration scale projects with gas companies, both injecting CO2 in coal bed methane wells as well as in shale gas wells, and we are still very active on this. And also looking at the potential of other, let's say, emerging shale gas plays that are close to our area. At that point, and after I had stepped down as a department head, the university had asked me to be a director of a center that we have at the university, which was called Virginia Center for Coal and Energy Research. This is a center that was established by the Commonwealth of Virginia, so it's a Virginia center, and Virginia Tech is looking after it. And as a director of this, it was an opportunity for me to much easier move into issues of energy and CO2 management. So we do a lot of that research through that center, and a lot of young faculty have received significant amount of funding and expertise in that area. So I wouldn't say we compete with our colleagues in petroleum engineering, but we work alongside with them because we do have significant knowledge, I think, on the issue of gas, and the issue of drilling wells, and the issue of injecting stuff. We've been doing this for a long time, and as you know, in mining, we'll be doing fracking, or what I think should be called hydraulic fracturing, for many, many years. So that is a way we diversify to these areas, which I think are critical for the coal industry, to be able to have ways of managing the CO2. So that is a bit of a summary of technical things that I have been doing or have been interesting, and I'm still looking for more things if I can find one.
With all of your technical work and your other work, you've received many honors and awards over the course of many years. Which has been the most meaningful to you?
That's a tough question. I think being an honorary member of AIME and SME is great recognitions, and I'm very, very happy with that. Getting an honorary PhD from a Russian university is something different that I value a lot. But I'm actually take a lot of pleasure on 3 awards that I got consecutively every year, every quarter, for teaching at Virginia Tech. It was the time that we first started teaching awards for faculty, and I got one every year for the first 3 years that I was there. So Dean Torgerson, that I talked to him before, he told me, I'm not giving any more to you. So he sent me a jacket every year instead of an award. And I thought it was very rewarding for me to receive this from the students on the basis of teaching. That meant a lot to me. But I do cherish everything, and although my wife complains at that point, my house have a wall full of all these things. So she says we cannot move to a smaller house. We have to move to a bigger house. So I enjoy and appreciate the recognition from the colleagues.
Michael, I've noted that you always take great care of your colleagues, which I appreciate. I've known you for 20 years since I was a student. And one thing I always remember is around the time of the mass shooting at Virginia Tech in the early 2000s, I was a graduate student, and we all had just come back to work, and we just didn't know what to do with ourselves. And you came down the hall and took a bunch of us out to lunch. I think it was a 3-hour lunch. And you really just wanted to check on people and make sure they were okay. And I wonder if you could just reflect a bit on how that was a seminal moment in Virginia Tech's history, on how the university has changed and how, for good and bad, we're still taking care of people.
Well, first, I have enjoyed working with colleagues. As you know, I work with people all over the world, and I know people all over the world, and they look after me as much as they look after them. I had the good fortune, in a way, to be a cancer survivor, as you know, and many people around the world send me notes. I do recall when a good friend, Indian colleague, told me he prays to his gods. Then the Chinese guy sent me about his Chinese gods, and my Muslim friend told me the same. So I keep these emails. I have appreciated that. It's always fun. We have so many capable people with a little bit of help. They can reach where they can be. So I enjoy doing that, and they all need a little bit of help at some point in our systems. The shooting at Virginia Tech was a terrible experience that changed profoundly people. I was at a meeting, I remember very vividly, in Washington, and I was on a table sitting beside the governor of West Virginia, who is now the senator of West Virginia, Joe Manchin. And my phone I had my phone on a vibration and buzzing, and my phone kept buzzing. And I looked, and he said there was a shooting at Virginia Tech, and I said, well, I don't know about that. And then he buzzed again, and then the number of deaths came up, and it was such a horrendous number. I thought, this can't be true, and I couldn't find anybody to talk to. And eventually, when people said it's just on the building opposite us, which actually from my old office was just next door, it was a shocking thing to realize. And as you know, all of us knew people that were involved in that shooting. And I think the faculty needed the help and support, particularly those who were there and could watch it really at that time. And the university was very good in closing ranks and providing motivation for everybody and help and support. And I think the university did that very well. And the president, who was a good friend, Charlie Stigger, did an excellent job for that. Beyond that, though, I have enjoyed working with people all over the world. and I have written letters for promotion and tenure to many people. I have helped people with research and papers, and it's good fun to do this. And I take a lot of pleasure when they do well. There is some of my students that will get awards in this meeting, as you know, and I much rather enjoy them getting it than me. And it's fun. It's part of the job, and it's a rewarding experience.